Hello, my name is Manav. This is Unit 1, Lesson 4 for Math 1 or Algebra 1. This is literal equations. Here are some review words that you just need to make sure that you know. It is that a variable is a letter that we use to replace an unknown number. Now, literal equations are going to be a new concept that you have not learned much about. But you may be asking, what even is a literal equation? Well, literal equations are meant to fool you. They don't actually have a real solution. Literal equation are situations where you rewrite the equation into another form. They're not meant to be solved. But, even more confusing, they follow the same method as solving equations to get to your final answer. They usually have no independent numbers, and they're used with formulas. The only time you will ever see numbers is if the formula has numbers in it. There are no general numbers, only numbers with the formulas. Now, you might be confused on what I'm talking about. So here's an example of a literal equation. When you're given a question using the words rewrite and terms, so for example, rewrite the equation in terms of blank, you have to use the idea of literal equations to answer this type of question. So for our example, I will be using the formula of the volume of the rectangular prism. For those of you who do not know, this is a rectangular prism. Here's the length, here's the width, and here's the height. And the formula for that is length times width times height is equal to the volume. This is a very simple example, but it's best to show what exactly I'm trying to explain. Our first question is to rewrite in terms of h. Again, with the keywords rewrite and terms, we have to take this formula and rewrite it so that it turns into h equals. Rewriting in terms of h means making h equal to the equation. So this is the original equation. We know this because it was said up here. Length times width times height is equal to volume. So again, as I said earlier, to solve this question, you have to use the same method that you would for regular solving equations. So we have to isolate h by using inverse operations. So what does that mean? We're trying to get h equal to this. That's what we said over here, which means we have to get rid of L and W from this side. Right now, we can see that L and W are being multiplied to h. The opposite of multiplication is division, which is what's happening here. Since that's what's happening, it leaves us with h on one side and all other values on the other, which is similar to what we had over here. Therefore, it leaves our new answer as this. H is equal to V divided by LW. So to rewrite in terms of h, we must get h to equal one side of the equation. Here, we have V equaling one side of the equation. Now, we have it equaling h. Hopefully that made more sense, so here's some more practice. I'll be using the density formula and the volume of a cylinder, which is a little harder. The density formula is density equals mass divided by volume. The question is asking us to rewrite in terms of m and v. And it looks like they already have it set up for us here, so let's rewrite. The first thing that we need to understand is that we have to get m, we're going to do m first, we have to get m by itself, which means that our final answer is going to look somewhat along the lines of m equals something. So first, we're going to have to deal with the one number that's stopping from this equation to look like that, which is v. Right now, we can see that division is happening over here, and the opposite of division is multiplication. So what we do is we multiply v to both sides. This crosses v out here, leaves us with m equals. And when we rewrite this, we get m equals, which is what our final answer looks like, d times v. Here's another one that's a little bit more trickier. This time, we're going to introduce numbers. But we're going to introduce numbers as soon as we find out in terms of v. So let's do the same process again. We know that our answer is going to be v equals some amount of numbers. Right now, what we see here is v being divided by m. So how are we going to get v by itself? Well, there's two ways to do this, but I'm going to show you both. The first way is to do something that we talked about a long time ago with fractions. It's to multiply by the reciprocal. If we multiply by the reciprocal to both sides, it leaves us with v over m times d. Oh my god. D times v over m equals something. We don't have a something yet, but it does equal something. Next, we have to get v by itself. So we deal with the number farthest away from v, which happens to be m. So since m is being divided here, we multiply both sides by m. We cross m from that side, leaving us with d times v equals m. Looky here, that looks the exact same like that. That's kind of cool. But our next step, we have to get v by itself. And the only thing that's connected to v happens to be d. We can see that d is being multiplied to v, and the opposite of multiplication is division. So we divide both sides by d. Since it's on both sides, it cancels out, leaving us with v equals m over d. Now let's try using it with numbers that are involved in the formula. This is the volume of a cylinder. The volume, in case you did not know, this is a cylinder. This is the volume of it. The volume of a cylinder is equal to pi times r to the power of 2 times the height. Essentially what that is saying is that the volume is going to equal the area of the circle times the height of the cylinder. Now our number is 2. Notice how 2 isn't an added number, rather it is a number part of the formula. So we have to rewrite in terms of h, r, and pi. So let's try that here. Again, we already have everything written out, and I'm going to move this to the side so that I have more space. Okay, h. We're trying to get this number to look, this equation to look like this number is over here. So that is h equals something. Now to get there, we're going to deal with the numbers that are connected to h. So as we see here, pi times r to the power of 2 is being multiplied to h. So something we can do to stop that is divide both sides by pi to the times r to the power of 2. That cancels it out here, leaving us with h equals v divided by pi to the r to the power of 2. Notice how we have h here, and we're trying to find for h. Now let's do the same thing with r. This is going to be a little bit harder. One thing that I notice is that since this is being multiplied and that's also being multiplied, we can get rid of these parentheses. Because pi is being multiplied to r squared is being multiplied to h. And we need to find r, so we need to find this. Not the 2, but this, which means that our final is going to look something like that. What we can see happening here is that pi and h are being multiplied to r squared. So we can divide both sides by pi times h, similar to what we did for this one. We can cross out pi and h on both sides to leave us with v equals pi h equals r squared. But we're not done. It doesn't look like this yet. It looks like this. So what we need to do is get rid of the square. If you did not know, the opposite or inverse of squaring a number is to square root that number. So x squared, the inverse of it is to square root. So what we do here is we're trying to get rid of the 2, which is being squared. So we square root both sides. That cancels out the square root here and the 2, leaving us with a final answer of r is equal to the square root of v over pi times h. And both our equations look the same. Lastly, we have to find in terms of pi. And the process is going to be pretty similar to what we did before. We can see that pi is being multiplied to r squared, which is also being multiplied to h. And we're trying to find pi. So the equation is going to look somewhat like that. The opposite of multiplication is division, and since we're trying to find pi, let's get rid of the other 2 terms. Whatever we do to one side, we must do to the other, leaving us with pi is equal to the volume divided by r squared times height. This is how you solve literal equations. And just before you leave, literal equations are not meant to have numbers unless the numbers are part of the formula. They are normally just rewriting the terms in an equation to make them legible or easier for you to find something.